Hello all, welcome to Ambari Cloud YouTube channel for LLM class. So in the previous video, I did an introduction to vector stores, and in this video, I'm going to walk through a step-by-step procedure of vector store, loading data into vector store and vector store properties, and then we will do deep dive on that. So before we need to start the Milvus Docker container on our machine. And here, if you look at here, then you're gonna start this container running this command. Then I will post this one command also. After you execute this one, then if you go to here, then I have a Milvus Docker. This is my image here. Okay, so Milvus Docker is running, and it is running at if you look at 19530 port. Remember those properties. And I'm going to set up my API key. So question, how to set up the API key. So you log into the OpenAI and you set up your account, and then you give a credit card, and then they don't charge you until you use it. But the amount of practice we do is very minimal charge. Then in our environment, set up your API key. So if you go to your right, right, oops. So in this file, right, the Mac, you can set up your OpenAI value, and then then using this load.env, it will read the API key, right? If you look at here, get the API key, then API key. We need an API key to make call to OpenAI to get embeddings. Okay, and we also already learned about the various libraries to load documents. For Milvus, right, then we're gonna run this vector store, Milvus vector store, and then we're gonna run this PyMilvus to have these are the libraries to set up a Milvus vector store. And this Milvus here is from LongChain. This is from Milvus library. Okay. So let's run that. So because we need to set up a connection, we need to set up a collection, schema, field, data type, all that, and depends on your design. Okay. So here, where is my Milvus is running at 19530 and is running on my local machine. But if it is running on remote, you need to provide the remote URL. So right now, I'm connected to my Milvus. Okay. So here, host. Basically Milvus connection. Here, if you look at here, connections, then we instantiate that. Okay. And so we have a PDF files. We saw previously how to read it and how to split it. One more time, load and split. Then we're going to do, chunks, right? And you're going to, I'm using character text splitter, but if you can use a reverse character text splitter. And then if you look at the document, then, we did the split. Now we're going to instantiate embedding, right? So we need, because then the embedding already has the API key, so we have we can do embeddings on it. Now we're going to, since I'm going to load invoices, right? And my collection name is invoice, right? And then if I want to start fresh, then, find out if the collection already exists, drop the collection, right? There's utility library available, so drop the collection, okay? Now let's go here. Let's look at any other collections are available here in my vector store. So basically list collections, utility list collections, right? Then I have, the other collections I'm working on, but I don't have an invoice collection, right? Collection index, we use both ways. Now, when you create a collection in vector store, you need to define the index properties. Okay. And then there are different type of index types. And then what is the metric? Are you going to use L1, L2s? So I will do a separate video about L1, L2, these indexes types. But think about these are based on the cosine, similarity, or Euclidean distance. They use those formulas to retrieve the data, and then when you store the data, right? So this is, IVF flat is a common, L2 is a common, right? And then additional parameters. So you're going to define the index parameters, right? Now we have an index, right? And we have index parameters, right? So Milvus from long chain has a method called from documents, right? What are the from documents? Pages. Okay, look at the pages here. I'm loading the pages, not the docs. You can also load the docs, doesn't matter. I'm loading the page because these are tiny. I don't need to split it. And then I'm going to use embedding model. What is my embedding model? This is my model, right? And then what is my Milvus instance running, right? And what is my collection name, right? And what are my search parameters? I want to do search, and then I'm going to use L2. And when I store, I'm also storing with L2 format, right? And then this is, what it does is this method reads each page, does the embedding, connects to this database, right? And then if the collection is not there, it's going to create a collection. If it is a collection is already there, it's going to load into that collection. And using this search parameters, basically it applies when you're loading into your embeddings. And if you remember, we did the embeddings here, and then depends on your embedding model. So let's run this. Okay, and then so index parameters are defined. Even you can also define your collection parameters here, right? You can make it as, but I want to show how. Okay, search params, right? Like that. Then you can use search params here. So, and then of course, as you're building an application, you want to get all these values from a config file. Okay, so let's load it. Okay, so it's loaded. Then I want to do, now it is basically when you create a vector store, and for a collection, now I'm going to get an instance of that vector DB for this collection, right? And so as not only you're loading it and then getting the instance of the vector store for this collection, which is running on this machine, right? In the Docker container. And this is my query. So now I'm going to pass the query, right? And what it does is it takes this query and converts into embeddings, right? Because it's already know this is embeddings, right? Then go into this collection and do a similarity search. Now let's run that. Now I got the docs back. Okay. Now I'm going to print those. Okay. These are the 4 docs. I got it based on my selection. Now let's do page content. Okay, so this is information based on my search, right? September 2022. Then these are the documents. So till it is not an exact search, remember that one. This is not like a database doing exact search. This is similarity search. Then it's going to return similar documents which are located near to this vector. Okay, for this vector, right? If you take this value and convert into embeddings, then you are comparing the embeddings of this document versus embedding of this document, all the stuff, then it will return. But it is a similarity search, it is not an exact search. But our goal is try to get as similar as possible, right? Then once we got these documents, and we're going to send these documents to LLM along with your question, right? Then LLM says, oh, I got these documents and I know the question. Where are these documents? Retrieved from your vector store. Then we're going to send this one to LLM. That means you are augmenting, right? We are telling the LLM, oh, LLM, you are superstar, you know everything. entire world, but you don't know anything about my invoices. By the way, take these invoices, and then I'm looking for my September 2022 invoices. Okay, I can send all my invoices to LLM and ask the question. I can do that. But if LLM accepts all my documents, because then it's going to be very expensive and slow. Why I have to send 2021, 2023, 25, and all, right? I want to send only September 22 related invoices. I might have multiple invoices on September 22. So we will send it to those, and then LLM will finally decides what you are looking for. Okay, in this document, September 22, show me invoice for Krishna or Bob. Maybe I have a September 22, I have invoices for many people, but I'm looking for, one specific person here, right? Right? For Krishna, I can do that, right? But don't assume that this one is going to give an exact set. It is going to give a similarity set. But LLM, you send me invoices of Krishna, Bob, Satya, right, Sam, but you're asking for Krishna, then LLM knows how to read these documents and finally to do a return to us. That's where we're going to do in the RAG modules. We will learn about it. Okay, so that is the key here. The similarity sets from your documents store giving you related documents. Now, if you have a massive network, when LLM wants you, why bother Milvus, vector store? You just give all the documents, but it is slow. Think about everybody's giving to that. But we will come to different architecture where if it is a tiny document, we don't store in vector store, we'll give it directly to the LLM. Okay, hey, this is my document, read and tell me. One of the example is patient and doctor conversation. This is small, right? And we give it to LLM, okay, read this document, give the summary. For that, you can still store in vector store and give it to that. But since, depends, right? Historical data will store in vector store, small, you can give it to them. Give it to the LLM. Them means LLM, okay? And so this is how you query the data. Now let's query again one more time. Okay. Yeah, still 4 documents, right? Maybe let's see 2025 if we have any. Yeah, so let's try remove the Krishna here. Yeah, it's still giving me I need to refine more September 25 invoices. Right. Maybe let's change the date. Yeah, I have very limited data, so 5 files, so you can't. Okay, and what is okay? The collection name is invoice. My search parameters are L2. My index parameters also kind of L2, not kind of, sorry, L2, and using the index type of VF flat. Then deep dive on, what is VF flat, and then there are different index types. I would not recommend too much time spending on it. Then just go with what is commonly recommended, that is VF flat. Okay. And what is the collection name again? One more time, invoices. And then what is the list of collections? Now I have invoices, right? And then, okay, let's get my collection back. Then what are my fields of the collection? That means the invoice, the index, right? So we didn't define these fields when we are creating the collection here, right? Here. The Milvus from documents automatically creates these fields: source, page content, right? Text, the vector store and all the stuff. All the information will be stored. This is how it is going to store your data. Now, if you don't want to use long chain, you can also do manually. You can create you can create a fields and then load into the fields. You can do that. Sorry. So let's run simple query. Okay, I want to know the primary keys, right? The primary keys, greater than 0, right? If you look at the field values primary key, every time when you load, it has a key auto-generated. You can also give manually if you are doing that, but Longchain is automatically doing it. So run this one. Let's say, okay, this is my expression, and these are for this expression. I want the output fields. Then I want to print. Let's try that. Okay, now look at this one. Print primary key and source. Now I can also print page just for. Okay. If you look at here, okay, page number, right? 1, 2, 3, because this is a big document, right? So these are individual documents, right? So you can query. You're querying the indexes, not the similarity sets. Here, what indexes you have, and you already know what indexes have for a given index. What is our primary key? What are the source and all? So you can do search on those. Then we already know how to. Now let's look at here one more time. Okay, collection query, vector store. Now let's run this one. Text. I'm for this primary key, right? And this is a text. This is how the data is being stored. Okay, and so here we are doing in a vector store. Then of course, then when you do a similarity search, is going to use a vector. Now let's look at the vector. Okay, now you see the numbers, vector numbers for this primary key, and these are vectors. And when they're stored in the dimensional space, and then when you ask for a search on it, and it also converts into vector and compares this vector to your September 22 vector and returns the text and pages for us. Okay. I want to delete a vector. I want to delete a document, right? So let's look at one more time. Okay. Now here, right, I want to delete this. I can delete by primary key. I can delete this page, this number, right? You know the document, right? So I want to do an expression source. This is a source, and the file name I want to delete, and then you can use a delete expression. Okay, let's run that. Okay, and I created a method. Pass the file name, then you query it, and then you for a file. You get build the expression, then you're going to delete it. Okay, so let's run file name and let's delete. Okay, look at this one, primary key in. Okay, so primary key in, because we got the primary key and we got a vector and we got a source, and then we're going to do, so basically here primary key in, and that is a delete expression. So basically is going to delete that. Okay, you can have multiple primary keys because this can be list also, because if you look at here, we are doing appending it. Okay, and so I'm going to delete it. Now I want to see that file exists or not, right? So always again, file exists, check the source, right? And if we get the link, if we have this file, and then if that means the response is greater than 0, if it exists, it not exists. Now let's create, check, yeah, file is not exist because this file is be deleted. Okay, now, okay, one more, then I'm going, okay, one more, okay, file not exist, right? Now let's use one more, yeah, this file, this is 08, this is 041, and then this file exists, and this file we deleted. Now let's say I want to insert it, right? Very simple. Remember that we did this, right? Just get a file and load it, and then load and split. Then you split it, right? Load and split. This is, we already know how to do that. Now we need to just call again this method. Now what it does is you send a file, it's going to load a particular file. Okay. Now I reload it again. Now that file exists now because we deleted that. Now if you know how to insert, now if you know how to delete, now you combine those into an upsert, delete and insert. Generally this file, whenever, let's say somebody says this file is changed, right? And what we do is we delete that file, embeddings, whatever that file embeddings, maybe chunks, right? We'll know how to get all those chunks using this, right? Here we can get all the values of that file because we are using the source of the, because if you have a chunks, chunks will have same file name for that file. Then we're gonna, if the file exists, we're gonna delete. If the file not, we're gonna insert. Of course, this is upsert. Because this is nothing like you open the file and modify a particular value, is not like that, right? It's all or nothing. You delete the file, insert the file. If it is already exists. So whenever there is so it's a common, right? Documents keep changing, right? And then, so this is then basically whenever you get a new document, you check it. If the document already exists, you delete and insert. If it is a new document, you insert. You follow these simple procedures, basically create a insert file, delete file, and upsert, combine those two. And this is a pipeline, you're going to build it, right? So files are coming in, you keep on, if you might have Watchdog, and Watchdog continuously checking files. As soon as you have a new file, right, you're going to run upsert, and then you're going to run these methods, insert method, update method, then you continuously running anything, you get a new file or modified file. Then that's how you want to maintain your vector store. Think about, let's say you have a document pages, every time keep adding it. Then you do maybe hourly, daily, depends on how often you want your vector store need to be updated. So very easy, right? All you need is understanding multiple methods, and then build small inserts and updates and check files. Then you will become an Milvus expert. So practice this, and then of course we will be continuously practicing Milvus everywhere as soon as we are moving towards vector store or RAG. But understand what is a query, what is index, and what is L1, L2s. Then how to do query, manual query through or vector long chain similarity sets. Mostly almost all we use a similarity sets, and then once you establish it, then you get a vector store, get good to go. Okay. So any questions, reach out to me, skondapalli@ambaricloud.com, and next video I'm going to talk about Postgres vector. Thank you.